I think we just start up. So I have the privilege to welcome all of you to the launching seminar or webinar for CircuitData. This is something that we've been waiting for a long time now, but finally we are here. This webinar will give you what CircuitData is, how to use it. We're going to talk about the organization and the way forward from today. So now we play some film.
My name is Jan Pedersen. I'm chairman of CircuitData. I have more than 40 years experience in the printed circuit board industry. One thing that has followed me all these years is the article specification and the lack of complete information. This is why CircuitData is so important for me, and we're going to tell more about this. CircuitData is only about the article specification. When I've been talking to people the last months about CircuitData, the assumption I normally hear is that this is also about fabrication data. But it's not. It's only about the article specification. It's not about ODB++, it's not about IPC 2581, it's not about Gerbers, it's not about PDFs or drawings, fabrication drawings. It's only the article specification. Let me give you an example. We have a designer that comes up with his design and the article specification. He has its corporate requirements, and then he sends the files to the EMS. They add their corporate requirements too. And maybe a broker that adds some requirements. Then this complete package with all these documents comes to the PCB manufacturer, probably in China. He needs to translate all of this, and there is no wonder that this becomes a chaos and a lot of questions back. Based on my experience and the example I just gave you, I think CircuitData will be a great contribution to the electronic industry. CircuitData is a language to communicate the article specification. CircuitData is also a complementary file to ODB++, IPC 2581 and Gerber. In this webinar, we will show you what CircuitData is and how you can use it.
What is CircuitData? As we said, it's an open language for communicating information needed for PCB fabrication. It communicates the PCB specification, it communicates the corporate profiles, and it communicates capabilities. In this presentation, we are going to take questions and answers at the end. You can use the chat mode. There is a chat field here. If you go to this GoToMeeting icon you probably have at the bottom of your screen, you can click that and you can type your question anytime under the presentation. And we will, or you can of course ask a question at the end. We would very much like to mute people when we are talking here, so it will be better to have the question and answer at the end. So I think we go to the next and try to play another movie.
My name is Andreas Lydersen. I'm the CTO of Informatica. Been here for 6 years, and I'm one of the co-creators of CircuitData. So when I first started, we had a system based on emails. We sent everything out by emails, and we received the quotations by emails. And we went ahead and started to make a portal, web pages where we could exchange that kind of information. And we thought that we were actually making the world easier for everybody in the whole supply chain. Now, it turned out that by doing things our way, we were actually part of the problem, not part of the solution. And it's been 6 years of constant development, and we finally figured that it wouldn't help what kind of system we created. We needed to have a common language. So that was the start of CircuitData. By creating a common language and having us all speak it, you could do stuff like compare a specification with a capability set in milliseconds. And you could add several layers of profile data in there and compare it and actually show the conflicts. Now, we've created a base, a starting point. But as a language, it needs to be community driven and it needs to be open source. So now we want more people to join in and start speaking that language. Just imagine the possibilities.
Okay, I guess I'll take it from here. My name is Andreas. I'm probably going to need a week or two to get over seeing myself on that video, but that's life, I guess. So again, thanks for joining. I'll be going through some of the technical aspects of CircuitData. Again, feel free to ask questions in the chat. And I'll try to address them while we go, and then there'll be a Q&A session at the end. So this whole language is based on the idea that communicating a PCB specification is a dialogue. It's not a monologue. And with the current systems, with communicating files, it has all the aspects of a monologue. So we've addressed it from that angle. It takes care of communicating small pieces of data or a lot of data, but it does that in a structured way. So let's just go through the language. The language consists of three parts. There is the words, the dictionary. This part is going to be maintained by the community, and then it's going to be set by a governing board. Now, by dividing it into three different parts, we make sure that it stays vibrant and that it can keep up with technology and needs. So I'll show you that on GitHub a bit later on. Then you have the syntax, and the syntax is more the grammar of the language. We've focused on JSON, which is kind of like XML. It could support XML also, but all the effort so far has been on JSON. It's based on another small project called Open Trade Transfer Package, which is also available on GitHub. And it won't change as often as the dictionary itself. JSON is a very mature and established standard. It can be read by any web browser. Now, the last part of the language is the schema. And the schema is comparable to a teacher or somebody who grades your papers. By running your files through the schema, it will automatically point out mistakes you made, any conflicts that you might have. So that's the three parts of the language. I'm going to try to swap now just to show you the progress of the language itself. So hold on a second. And there we go. Okay, so GitHub is a place to share code, and our dictionary is a set of code. So you can find it on circuitdata.org. You'll find the link to it. You'll find all the revision history, everything you need. It's become quite substantial already, and I won't bore you with the details, but it runs quickly through the syntax, and then it goes into detail. So
Andreas, I think we only see the presentation.
Okay, sorry. Try to go out of full screen on that one. And
yeah. Thank you.
Okay, good. Thanks. Again, it's on GitHub. You'll find all the revision history in there, but most importantly, you'll find the whole dictionary in there. It's structured in a way that should be quite easy for any developer to follow, but also anybody who doesn't actually do code. It's a dictionary. So far, it's covered our needs, but again, this is supposed to be a vibrant dictionary. So as soon as other needs are discovered, they'll go through a process and then become part of the dictionary. So that's the GitHub page with the language itself. And again, you'll find it on on CircuitData.org. Okay, I'll try to swap back to the presentation. And there we go. Okay. So just to remind you, CircuitData, a language divided into 3 parts: the dictionary, the syntax, and the schema.
You are still in
presentation's not up.
GitHub.
Okay.
Sorry about that.
Well, thanks for letting me know. Let me try to do that again then.
There.
And like that. So you're seeing it in presentation mode now?
Yep.
Okay, good. So if we are to succeed with this, we need to have a whole ecosystem of different parts that are using the language. And the obvious means of exchanging data is by files. So sending files by email, transferring files system to systems, that's the obvious part. Then we are trying to create a set of plugins. Now, plugins can be anything that connects a system to the CircuitData language. I'll give you a demo of that in a little while. Software. Examples of software could be things that are custom made for CircuitData or existing software that use the CircuitData language to create files. ERP systems, obviously, many times through plugins. Then you have platforms. And platforms are interesting. Platforms are for constantly exchanging data. We are talking about data that are changing, so just sending a file is actually sending dead data. Platforms allows 2 systems to connect and stay connected through that platform. And lastly, I want to mention that as soon as you have a language, you can start doing interesting things with it, like artificial intelligence and using algorithms to compute changes over time or needs that keeps on popping up. First example is a plugin. So a plugin is mostly a set of functionality that is bundled together into something which is usable by a system. And we've done most of our code so far and bundled it into a plugin for the programming language called Ruby. And Ruby calls their plugins gems. So on the web, you'll find our CircuitData gem. It's open sourced, and it consists of several different functions that makes it easy for a developer to implement this into their own system. Or it can be used as an example for other languages. So I'll give you just a short demonstration of that. Let's try to do it right this time. Now this is kind of technical. So if you have questions on that, just let me know. I'll touch on the Q&A session. So I'll have to give you this example in code, but you actually it's possible to have a whole set of functionality included into your code or your application with just 1 line of code. You just require the gem. I'm going to import a test file just to demonstrate. And then you can start calling functions from it. Now in this very short example, I'm just running it through the schema. Remember the teacher I talked about that automatically looks into your code? This one does that and then outputs it in a way that makes it easy for a developer to see what the actual problem is. So in this file, there's a typo. So instead of rigid conductor layer with a C, there's a missing C in there. By using plugins like this, you can take development time from weeks or months to just a few minutes. And as you can see, CircuitData is fast, and like anything which is digital, it's only constricted by the computing power. Okay, let's try to swap back again. Are you seeing the presentation now, Jan?
Yes, I am.
Okay, perfect. Now for the second part of the demo itself, I'm going to let Josse take it from here. My colleague in Elmatica, Josse, I'll make you presenter.
Okay.
Yeah,
you can hear me, and hopefully you see my screen as well.
Yep.
Yeah, good. As Andreas said, he called me Josse. That is correct. My real name is Jon Steinar Johnson, and I'm a senior technical advisor at Elmatica. What I'm going to show you here is just a brief sample. You can say the specification itself. What you see on the right side here is some of the stuff that we want to have with us into our specification, and it's missing a lot, but that is up to the common members of CircuitData to suggest, and we will add it in. This is a rigid layer board, 8 of them in total, and here what is marked in green is actually what has been added in the specification. So I go down to it here. You can see minimum track has been added, minimum external track width is added, minimum internal spacing is not added. We can add it. It could be a 0.12 millimeter, 12 micron, and also when we come down here to external base copper thickness, the values you will see is the same values defined by IPC. So it's a menu you can pick from 240 micron. It's a lot. Further down here, for example, on inner layer, 7.5 micron. And I will go up again, and we go a little bit further down. Look at the board here, for example. You have the size in X and Y and the thickness. This has also been added, and you see it here. Board starts up here, and in this case, I have put it in enforced. Let's say you are one of the only one maybe customer who run only 160 by 100. It's a single Euro board. It's enforced. Every time you do it, it's 160 by 100. And thickness is 1.6. I would rather say that customer doesn't exist, but still, it's just to show samples. Further on, we have an array, sub-panel. Also here, starting with the array here, you have the size. Typically, the X dimension was 100 millimeter for the board, so it's added up 2 times. There is 2 millimeter, which is the same as the router bit in between the boards, and there is a frame of 15 millimeter. Makes the total width of the sub-array 232 millimeters. Further on, you have a height. There are also 2 there, 2 boards up, 160 by 2, plus 2 millimeter in between, and a frame of 15 millimeter. Typically here, There are two boards in X and 2 boards in Y. And left border, right border, top border is specified. And also bottom here. Okay. So this is the way things can be added. I will show you another thing here. This is how it can, I guess the screen is, sorry?
Yeah, just a short question on this. So basically, as we would deliver here from ILFA PCBs, so Elmatica would fill such a specification, and we would basically fill in the same way our profile, correct?
Yes, correct.
Correct. Yeah. And if we have filled our profile and you fill for each single board the specification in these fields, you can do an automatic comparison whether it falls within our profile or not.
That is true.
Yeah, that is right.
Okay.
So what you also show you is just is how to define a profile. Your default answers if there are no answers in the other files. Your restrictions, so what is never allowed in our board, or your enforced, which is what is always true, even though there are other answers in other files. Yeah.
And that's okay. Enforced, if you have specific demands for delivering the board, it could be special way of packing it. You can put it in as enforced, and it's a company standard in a way. Okay, what you see here, let me first explain what you see here. Integrator. Integrator is a program from Ucamco that we are using on all data we receive from customers around the world. Normally, it's a zip file. It can be with a IPC 2581, it could be a ODB++, or it could be Gerber extended or basic Gerber without apertures included, actually presented with separate Gerber tables. So integrator is analyzing the IPC, the zip file, for example. It could be a RAR or whatever. And we get a specification in a way out of the integrator file. And we read that file into the specification that we see here. Typically, it analyzes the Gerber files and find that, or the data specification from customer, and find that the external copper base, for example, should be 34.3 millimeter. There should be a track width internal inner layers to say 0.14, and minimum external spacing here is 33. So what we see here in the summary, it's what we have got in as data. If we go one step further here, you still have the integrator file, what we received here. But now we also have got maybe some feedback from a manufacturer that's telling that they do not find 34.3 as we do from integrated. They find another track width. But in this case, it's the same. So the red one here is conflict areas. And if you see on the conflicts we have, oops, I went a little bit fast on that one. Let me go one back. Here. The copper foil roughness, for example, it's specified here from the PCB manufacturer as a low profile, but we have an EMS who is also into this PCB. They have specified a standard profile on the copper roughness. So we are able to go in and just set what is the standard. Okay, let's find it as the EMS profile. It's a standard profile. And we set that and we have a green light to go further on. Okay. So I don't know if I should say something more about this, but I just want to say that there is a lot of issues still missing to make this as a complete stackup. Typically, when it comes to materials, how to define a stackup, copper thicknesses, dielectric thicknesses, what bill of material to use, and so on. So there is a great job in front of us for those who will be working inside CircuitData. I think I'm done, Andreas. And as you said, we take the questions at the end of the presentation.
Okay, thank you. So I think the main purpose of showing this is to show that we're trying to reflect the way the supply chain actually works, that you get bits and pieces of data, and most of us spend a lot of time comparing data manually. With this, you have the opportunity to actually compare data automatically and highlight the conflicts. In that gem I showed you, the plugin, then you actually have the option to feed it several files and have it give you an output with the conflicts. Okay, I'll take back the presentation and yeah. So we talked about the ecosystem and how we have the gems or the plugins, files. Just to give us a couple of examples of software that could be used to utilize such a language. ERP systems, we all have them. We could have them talk the same language. And then I'm going to talk about platforms. Now, sorry. I'll give you an example here too, and I think I'll actually have to stop this one, and we'll go back to Safari. Okay, so normally we're used to sharing data like this. It's written down into a PDF, and it's sent out together with a request for quotation or an offering of some sort. Now, together with that now, we offer this button where you can download CircuitData files. And if we do that, and then look at a file like that, it would look something like this. Contains at least information we have in our system, and a lot more could be added, a lot more could be taken away, but the language just facilitates giving that to whomever in the supply chain who needs it. So I'm just going to browse through it to show you quite quickly how that would look. To go back again, a platform's purpose is to keep on exchanging that data and to connect ERP systems live. So I'm going to show you that in a system called Commodity Live. Yeah, so quickly just creating a product, giving it that name we had from the file, and it's just called Emotica. So now we have a product. Commodity Live utilizes the CircuitData language, so I'm able to actually import that file we had. So this opens up a lot of possibilities. For instance, it can recognize the file and automatically add standards to the product itself. So it found out, okay, it needed UL listing. It found the IPC classes. So it just assigned the standards. Of course, have all the specifications of it. and a couple of classifications as it's found that it's a printed circuit board. So HS code, UNSPC can be added in here. But the important thing about a platform is the fact that you could exchange other stuff like lifecycle states. So we could, for instance, say that this one is end of life, and just give it a link to somewhere where more information can be found. I think the main message that we want to get out here is that as soon as we start speaking the same language, there is a whole new world of possibility is opening, where we could follow the natural flow of the PCB from the designer all the way throughout until we reach the manufacturing, and then back again, and get the updates back to the product owner who actually owns the data, without anybody tampering with any files. Just keep on adding bits and pieces of the truth that ends up back with the product owner. Okay, let's switch back again. So to sum up my more technical run through, so this is a computer readable PCB specification. It consists of the language itself, and we've also made some tools to make it easy to link with your existing software or your ERP systems. Files can be added all the way throughout the process. It caters for profiles, which is requirements and the documents that usually follow the specifications today. And it caters for capabilities. So you could match up your supply capability with a product and get an automatic result out of that. It takes away the need to exchange PDFs or Word document or Excel sheets. So it's all machine readable. It's a very time and money saving process, but it will take us all start to speak the same language. So the goal here is for everybody to stop punching and go into directly importing data. That would ultimately both save us time and money and take away the issues that I think we all see today with engineering queries that cost us days of the field states on the delivery time, and the confusion that often ends up in quality cases. And with that, I'll pass it on to you, Jan.
Yes, thank you so much. Okay, so how do we organize circuit data, and where do you find it, and so on? Circuit data we have been organized in different forums, and what you see here is the 5 elements that we want to bring into the organization. We have a circuit data forum, we have an advisory board, or we're going to have. We are creating a governing board, and we have a LinkedIn page, and we have what I've just been talking about, the circuit data tools. So let's go and see how we are going to work with each of these different elements. The open page, if you can say it like that, where everybody can find us, is the LinkedIn page, where we can discuss. Of course, people can ask the questions, what it is. Everybody can access it, and it's an open area where we have news posts, where we can recruit people, and we have open discussions. And then from the open LinkedIn page, we go to the forum. Next, Andreas. Thank you. The CircuitData forum, that's a membership forum where you can just, people can not just go in, but you can send an application for membership and you will certainly get it. Inside there, we have discussions that goes directly on the language itself. It's a place where we can suggest new elements, discuss parameters, discuss colors that needed in SolidMask, and so on. And it's a source for the advisory board. And then we come to the next step, and that's the advisory board. That is a kind of task force where we ask people to come in and do a project, work in a project on limited time. If you are a part of this task force, and if you go into work in the advisory board, you're not there for a long time. You just step in, do a job, develop something, discuss something, and then you can step out again. So it's a task force that is, I would say, it should be easy for everybody to do something, and then don't feel that you need to spend a lot of time there. The advisory board, when they have discussed a solution, they give this solution into the governing board. And that's where we have created this governing board as the highest level, where we decide, should we put this discussion, this element that has been discussed, maybe it started in the open forum or in the LinkedIn, went through the advisory board, and then comes in as a suggestion to update the language. Those things are the things that we want to do in the governing board. We say that we should be at least 5 people there. Today, it's myself, Jan Pedersen, it's John Steiner Joseph, and it's Dr. Andreas Gombert. I'm chairman for the moment, but that's only until I step out or we decide that somebody else should be the chairman. And the governing board is, we're going to have the first, constitutional meeting tomorrow. So this is pretty new. And whatever has been presented here, of course, this has been initiated and it can be changed. Depends on what the governing board and the forum decide to do in the future. So we have put a few milestones up, not much for the moment, but the main milestone has been to date to reach this point. Tomorrow, as I said, we're going to have the first, or the governing board constitution meeting. And from that, in that meeting, we will set a few milestones and some plans, and all of this will be given into the open forum so that everybody knows what's going on. November 10th, Elmatica has been so kind to release, they will release a profiling tool. That's the tool that you saw Joseph working with. And November 11th, since that's the day after the profiling tool, we will of course handle this tool into the governing meeting and assign tasks for an advisory team. So at that point we will start to work in an advisory team to develop further the standard or the language. And as you see here, Q1 18 sometime, CircuitData revision 1 will be released. And again, when that will happen depends on how fast we're able to work and what's going to be decided in the governing board. All the minutes of meeting in the governing board will be released into the forum as an open document. There's no hidden things here, so everything is going to be open. And all the news, minutes of meeting, this presentation that we have seen now, probably the recording of this presentation will also be available in the forum. So that is basically what we wanted to give as a presentation today. A little bit sorry that these 2 movies we had, they were not the best. It's sometimes a little bit difficult to show them in these GoToMeeting webinars. But guys, do you have some questions? We are open for receiving questions. Please feel free.
Do everybody know the consequence of open source? It's important for us that we, we're giving this away, the stuff that we've made so far, and we want to still keep on contributing, but we also want to show the source code itself. So does anybody have any questions on that? Then please let me know. I see there's a question there. Do you interact with IPC in this project? Jan, do you want to address that?
Yes, we to interact with IPC. Absolutely. I mean, I am member of the IPC 2581, and we have a discussion. I see that Nancy is online there. And we have a discussion, and we're going to discuss more how we can interact this into the 2581 and how we can cooperate not only with IPC but with our other standards and other groups also. But yes, IPC is one of the, IPC is the one that creates the standards for the PCB industry. So we have to cooperate with IPC.
Yeah, so Gary asks, how will IPC and IEC be represented from a technical direction industry convention perspective?
Industry convention perspective, yeah. I don't think we have come to a stage where we can answer too much of this yet, but how would I say?
I mean, this is community driven, so in a sense, as much as IPC wants to be involved, and same goes for IEC, then perfect. The standard itself, or the language itself so far, has been based as much as possible on the IPC T50 standard, right? And and if you look into it, you'll see that we are referring as much as possible to IPC.
Yeah, if that's what the question, that's the content of the question, I can say that everything we do is based on IPC standards, and that's IPC terms also, T50. So everything we do is based on IPC terms. We need to, that's a part of speaking a language.
We definitely want to be part of the solution here, so we're not trying to create something new, we're just trying to structure it in a way that reflects the reality that we're part of. Arthur asks, any interaction with major PCB CAD companies to embed CircuitData specifications on their software some way? I guess I could answer that. We do have some dialogue going on, and the main response seems to be that if we get traction, then they will add it. So if enough people ask for it, then I'm pretty sure that will happen at some point.
Josse here, some comment. I don't know if we have Altium with us in this meeting, but for those people who are doing the CAD work, doing the layout, it could be a dream. Just push the button and you have the JSON file out as a specification together with an ODB or a IPC 2581 file. It's all there.
Yes, maybe also be able to mash up a profile within your design system so that you could see conflicts before they appear.
Yeah.
Going back a little bit to Gary's question there, we will have a meeting. I'm going to be away now for 2 weeks in Asia, but when I'm coming back, we are going to have a meeting with IPC and the 2581 task group to see how we can find a way to cooperate. There's been a question whether the CircuitData could be a subgroup of 2581. I'm going to hold a presentation also in the design forum at Apex in February, end of February, start of March next year. So I think the discussion how to find a good way to implement or interact is maybe a better word between CircuitData and 2581 is a discussion, and I think it will benefit both parts. This will be a good solution there.
Any other questions?
Yeah, please. Well, if there are no other questions, you can always, if you step to the next slide, Andreas.
Sure.
There's always the possibility to communicate there, and what we would like to do is that the questions and discussion, you can do that in the CircuitData forum. That means any questions you have, it will be, of course, available for other people, and that's also brings up a good discussion if people comment back. Both myself and the other guys that voluntarily now work with CircuitData, we will, of course, be very, very active and make sure that you get answers. Please come up with suggestions. And if you don't feel that you got a full understanding in this webinar, there's a possibility to contact myself also, or any others of people working with CircuitData. I also like to say that this initiative started, of course, from Elmatica, but it's handed over now to CircuitData as itself, and gradually this will be not maybe released from Elmatica, but we working in Elmatica will have a smaller and smaller impact to CircuitData as more people come in from other companies, and that's what we want it to be. That's how we can be open source and not linked to one company.
There is one more question here from Milosnik.
Yep.
Okay. Still not clear what the major difference between your proposal and the goals of IPC 2581 and the ODB++. Yours is the language, the other are file formats. Yes. If I'm allowed to answer that one, I would say that the major difference is that both 2581 and ODB++ are, as you say, formats. They are based on having one file that has the whole, that contains everything, while this one is a way of just giving small bits and pieces of specification that comes as you move throughout the supply chain. Another major difference is that it's also it holds the possibility to give requirements like profiles and capabilities, so that they can easily be matched up. In my experience, all these are multiples. So one company can have multiple requirements. One PCB house could have several capability sets. You could have one capability set for all your capabilities, one capability set for just your sweet spot where you want to manufacture, where your prices are best. And this repeats itself. I mean, you have everything is multiple. Oh. So with this, that it respects this fact, and it's supposed to be a supplement to 2581 ODB++ and Gerber. We're not trying to compete with anybody, but in our experience, it ends up with a lot of file. Now, as your question is, the goal of IPC 2581 and ODB++, I think the goal is pretty similar. Everybody wants to have the whole business speak the same language. We're just addressing it from a different perspective.
Yes, but you said that one PCB factory can have different capabilities. We have some very good examples of that, where one of the factories that we are working with is if you ask about a flexible board, you will have a set of capabilities that is very different from the same company producing a motherboard. And if you have a motherboard or a back panel combined, or if you compare that to a rigid flex, which could have many of the same parameters inside, it will be very different. So yes, one factory can, with this system, they can actually distribute multiple set of capabilities, which is what they actually do today. But sometimes they communicate this as a combination of everything, which they cannot do. So this is, if we succeed with what we have started to do here, it will be a much better communication between all parts of the value chain. Further questions, please? We have time for it.
And if you have time, then please join and be part of creating a language. Languages are beautiful things. I mean, we can all join in on a conference like this and speak the same language. And we're hoping to do the same thing for the printed circuit board industry.
We will give some further presentations. We will in Norway. People from our country here. We will have 2 presentations, in one in Arendal and one in Kongsberg. That will be in the And as I said, I will have a presentation in the US at Apex 18, and we'll probably have further also. And we can certainly have other webinars like this. It will be more of them, and as a part of CircuitData, we're going to say milestone and plans, we will have a webinar each time we release a new version. And I hope that we can reach out to everybody and to get a good understanding of what we are doing. But if we don't have any further questions, I think that we say thank you so much for taking the time with us, and we're looking forward to see you all in the forum. And please contact us if you have any questions further. Thank you so much.
Thanks.